My name is Aaron Brackman, and I'm going to be presenting today on deep neural networks and deep learning. So what is deep learning? Well, it's a branch of machine learning that mimics the human brain and how it learns by absorbing information and recognizing patterns. The concept has been around since about the 1950s, but has basically been majorly improved on today with better pattern recognition. So deep neural networks throughout history started back in the 1950s, as I said. The concept was that you would build components that mimic the human brain, and then once you've built all these components, you just kind of piece them together like a puzzle. And once you've done all that, then you have a fully functional AI that mimics a person. So it sounds easy, but let's see what kind of happened back in the 1950s. Building the neurons and things that act like neurons is an easy task. Putting them together in a meaningful way, however, was not an easy task. And in the 1950s, everything was kind of done on single-layer neural networks. And what was discovered by Minsky and Parfret was that you couldn't teach a single layer of neurons to learn much more than what you wanted them to learn. So we go ahead and fast forward to the 1970s, where now we're trying to work with multi-layered neural networks, and backpropagation was invented. So using this technique, you actually could teach a neural network to learn anything that a human could learn. But the catch here is that it was just way too slow to have any sort of meaningful gains. And that if you had gone with the techniques they had back in the 1970s, you'd never see an AI that could approach human intelligence. So what were some of the drawbacks with that? Well, one of the problems was this thing known as a vanishing gradient. And that is when the machine became reasonably good at a task, it stopped receiving good information on how to prove the task further. It stopped looking at the lower levels because it knew how to do the task reasonably well. So the problem in this is that you didn't configure it to look at the lower levels. Really the lower layers can dramatically improve your performance in the upper layers, but it's only when the task is essential, or when the lower layer is essential to the task at hand. So you can configure that, but then your backpropagation takes forever to do, and that's why it fell out of favor in the 1970s. So let's go ahead and fast forward to today, where deep neural networks are really extremely popular. And with backpropagation, they're vastly outperforming anything else, and the key here is pre-training. And so basically the lower layers absorb the structure from higher layers, so they don't have to do as much work, and the lower levels deal in raw data, and the higher levels extract features from features. So for example of this, if you look at a facial recognition software, your first layer might say, okay, that picture of a face the lowest level might say that you've got a mouth, ear, nose, etc. on a human. But then higher levels might say that there's more features about those things. For example, spacing between the eyes or brown hair, things like that. And then looking at pre-training, if you look at, there's two techniques that were used. So the first one is autoencoders. An autoencoder is a neural network that learns to reproduce its inputs and as outputs. So in the case of the facial recognition software, again, you wouldn't memorize how the face looks because you're not trying to store pictures of the faces. You're trying to store features about the faces. So, for example, you have two eyes that are close together, a small nose, a large mouth, two small ears, etc. And then what you're going to do with the autoencoder is that after that layer has been trained, you train the next layer off the previous layer that was trained. So the next layer may say just mouth, ears, nose, etc. And then from after you've trained all the layers, you can backpropagate and fine-tune your system to work even better. Another way to train your system is with a restricted Boltzmann machine, and you would do that if your data is noisy or statistical, and then this allows you to reproduce that statistical data. Once the first RVM has been trained, you can use it to output to the next layer, and so on until the entire network's been trained. And then after you've trained the entire network, you remove all the scaffolding of the RVM, and then you just stack the layers on top of each other and backpropagate to train the neural network. So let's take a look at some examples of deep learning and how they've fared in recent days. In October 2012, there was a group of students who entered a contest to help find molecules that might lead to new drugs. They fed it a very small sample of data, just thousands of different molecules, and the deep learning software determined which of the molecules were most likely to be effective to be an effective drug agent. And actually won this competition. What was really impressive about this that the students didn't have a lot of intimate knowledge about the subject, and it was a very last-minute entry. So the fact that it outperformed everything else and won the competition was very impressive. In 2011, scientists at a Swiss lab won a pattern recognition contest by outperforming competing softwares, the human experts, outcompeting human experts and competing softwares, and identifying German traffic signs. And you can see the kind of numbers here out of 50,000 signs. It was extremely accurate, far above what a normal human could do, and then above what the average human in the competition was able to do. So in conclusion, deep neural networks act similar to how human brains are, but it's not really an exact one-to-one. If you look at it, how infants are kind of done, they're not pre-taught or programmed, they just kind of start learning. With a machine, you have to teach it and have to train it to get the type of gains that you want to get out of it. So major breakthroughs are still being made today if you look at what Google did with their AI and Learning Go. And there's a ton of different examples out there today. But I hope you enjoyed the presentation, and thank you very much.